Assalamualaikum warahmatullahi wabarakatuh. My name is Arnie Novianti. I'm from International Program on Science Education 2019. So I would like to presentation about Newton's law of motion. What is Newton's laws of motion? Newton's laws of motion are three physical laws that together laid the foundation of classical mechanics. They describe the relationship between a body and the force acting upon it and it is motion in response to third force. More specially, the first law defines the force qualitatively. The second law offers a quantitative measure of the force, and the third asserts that a single isolated force doesn't exist. These three laws have been expressed in several ways over nearly three centuries and can be summarized as follows. Newton first law. Newton's first law states that every object will remain at rest or in uniform motion in the straight line unless compelled to change its state by the action of the external force. This is normally taken as the definition of inertia. The key point here is if there is no net force acting on an object, if all the external force cancel each other out, then the object will maintain a contained velocity. If the velocity is zero, then the object remains at rest. If an external force is applied, the velocity will change because of the force. We can say in here, V equal constant, sigma F equal 0, then dV over dt equal 0. And Newton second law. Newton's second law is quantitative description of the change that a force can produce on the motion of a body. It states that the time rate of change of the momentum of a body equal in both magnitude and direction to the force imposed on it. The momentum of a body is equal to the produce of its mass and its velocity. Momentum, like velocity, is vector quantity, have both magnitude and direction. A force applied to a body can change the magnitude of the momentum or its direction or path. The Newton's second law is one of the most important in all of physics. For a body whose mass m is constant, it can be written in the form F equal m times a, where F force and a acceleration are both vector quantities. If a body has a net force acting on it, it is accelerated in accordance with the equation. Conversely, if a body is not accelerated, there is not net force acting on it. Yeah, we can see the formula F equal m mass of the object times acceleration. And the last Newton third law state the when two bodies interact, they apply force to another that are equal in magnitude and opposite in direction. The third law is also known as the law of action and reaction. This law is important in analyzing problems of static equilibrium, where all forces are balanced, but it is also applied to body in uniform or accelerated motion. The force is described as real ones, not mere bookkeeping device. For example, a book resting on a table applies a downward force equal to its weight on the table. According to the third law, the table applies an equal and opposite force to the book. The force occurs because the weight of the book causes the table to deform slightly. So there is the pushback on the book like a coiled spring. Uh, in we can see in here the formula Newton's third law, right? Ah, in the 20th century, Newton's law were replaced by quantum mechanics and relativity as the most fundamental laws of physics. Nevertheless, Newton's laws continue to give an accurate account of nature, except for very small bodies such as electron or for bodies moving close to the speed of light, quantum mechanics and relativity reduced to Newton's law for larger body or for body moving more slowly. Thank you. This from me. Assalamualaikum warahmatullahi wabarakatuh.